So here in this example, we're going to see a situation where we'll be rationalizing our denominator in addition to dealing with imaginary numbers, solving by taking square roots, solving polynomial equation, yada, 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 you name it. So let's get into it. Here we do not have a difference of two squares, and we don't really even have so much a sum of two squares. I could get into how we can maybe adjust it a smidge, but I think that using some irrational numbers and minus negative better served on a different example. So I'm just going to solve this one by taking square roots. We're going to start by subtracting 1. You don't want to take square roots until the x squared has been isolated. So 2x squared, not good enough. What do we got? 2. X squared is negative 1. Divide both sides by 2. Those two 2's reduce to give us 1. We don't say cancel, reduce or simplify. Thank you very much. X squared is equal to negative 1/2. Now, we're going to take the square root of both sides, and when we take a square root ourselves in an attempt to solve an equation, we need to be considering all possible answers. We put a plus, minus in front. Next, the square root of x squared, we are going to write x. Now, how do we deal with this? Plus, minus, fraction, negative, this is where a lot of people are quitting, right? Wrong. We can do this. Plus, minus the square root of negative 1 over the square root of 2. All right, let's keep it moving, a little at a time. Don't you worry your pretty little face. Where are we going now? Well, x equals plus minus. What's the square root of negative 1? Did you say I hope so. I hope so. Sorry. Over square root of 2. Well, it's really square root of 2. Are people going to write down 2? Yeah, they are. Why? I have no idea. I have absolutely no idea why people do the things they do sometimes. It's like you just want it to work out nicely and don't think about the fact that it just doesn't. So we're here right now. We are not supposed to keep an irrational number or a square root radical of some sort in our denominators. It's just an agreed upon rule in the math community, especially when we start dealing with trigonometry. Now, it takes a pair to make a square. So I need to multiply both my numerator and denominator by square root of 2. This is actually the number 1. Anything over itself is 1, except 0 over 0, but root 2 over root 2 is equal to 1. 1 is the multiplicative identity. You're allowed to multiply by 1 because it doesn't change the value of something. It may just change the appearance of it instead. So root 2 times root 2. That's also, here's your thought bubble. You could also think of that as square root of 2 times 2. And it takes a pair to make a square. What is the square root of 2 times 2? You don't need to write square root 4. Nobody has time for that. Knock it off, okay? You're in algebra 2. We're not babies anymore. What are you doing? It's 2, okay? Just write 2. Please stop writing square root 4 in between. No need. No need. It's ridiculous. So, x equals plus minus I root 2 all over 2. And that is it. We are so smart and happy. Okay? Those are our two imaginary solutions. We had a second degree or quadratic equation that we were solving, polynomial equation, and we found 2 answers, imaginaries. Imaginaries come in pairs. This looks good to me. Sounds great. If you were thinking of this as a graph, x squared is normally a parabola at the origin. 2 made it a little bit more vertically stretched, a little bit more narrow, and plus 1 shifted everything up 1 unit. So we have a sketch of this parabola, and we're really solving a system of equations by solving this of where y equals 2x squared plus 1 and y equals 0 intersect. Well, y equals 0, that's the x-axis. Do they intersect at any real location? No way. they do not. So that is going to explain our negative solutions. And that's all there is to it. Hope you were able to wrap your mind around all this. I hope you are remembering how to rationalize the denominator. I hope you are efficient. Hopefully there's a video on the screen that you want to click to and get more work, more practice. And if not, check out the playlist. Have a great night. Adios.